Good afternoon, everyone. Thanks for listening, or coming out anyway. If you fall asleep, never mind. So, just get organized here. My name is Terry Regier. I've been doing HVAC sales and design since 1979. Currently, I'm a branch manager at Echo Supply Victoria. I've been a TECA volunteer for 20 plus years. Really quite involved in the association for a long time. Also, I am certified with the North American Technician Excellence Program. That's not really that common in Canada. It's really big in the States. And in 1990, I built an R2000 home. Built my own home. Lived in there for 26 years, raised my family there. So today we're talking about in this session we're talking about the ventilation guidelines. And there's been a couple of changes to the 2012 guidelines that came out there, 2012 building code. 2014 amendments to the building code section 9.32 have brought the biggest advancement to residential ventilation in that section's 30-year history. Finally, an effective control against high humidity, indoor humidity. The biggest upgrades from the previous code, and we did steal a little bit from ASHRAE 62.2 in the process. We found that was the direction we were wanting to go, and it just made sense to use the research they'd done and adopt it into the BC Building Code. I don't know if you guys know, but the BC Building Code is quite different from the National Building Code in terms of 9.32. We ventilate at a different rate, and in my opinion, and many people's opinion, it's more logical. So the first big change is that we now require continuous fresh air distribution to all bedrooms. That was not in previous codes. And obviously bedrooms is the place that you spend the most time in a 24-hour period. It made sense to actually change the air on a continuous basis in the areas where you're sleeping. The second, because of that continuous circulation, we also have gone to continuous exhaust or continuous ventilation of the home. So no more dehumidistats, no more timers, anything like that. We're just gonna have that fan run 24/7, but it's got to be quiet. Secondary suites have now been written into and addressed in 9.32. The secondary suites also must be ventilated, very similar to the primary residence, a little bit differently, but this is a really important point because secondary suites are very high occupancy for the square footage or the cubic volume of that dwelling, and tended to be a real mold and mildew factory. So it was a really important step to include that. The other thing that's now included in 9.32 that wasn't in previous generations was crawl space ventilation. So they've given you 3 or 4 or 5 different methods of ventilating the crawl space, whether it's heated or unheated. And finally, one I was pretty happy about is they removed any references to radon from 9.32. So we're not worried about radon mitigation in terms of 9.32. That's left in other parts of the code in terms of mitigation. The general feeling, and speaking to engineers internationally even, the reason it was originally in there is it was thought that by having the building under negative pressure, it could possibly cause more radon to be emitted into the home. And I think the quote was something from one engineer was, for that to be true, the negative pressure would have to be equivalent to a jet engine. In fact, the consensus was that any ventilation of a dwelling actually reduces the amount of radon gas, actually improves the air quality. Is that generally true, David?
Absolutely correct. And I agree with you totally. I'm glad it's out from underneath the ventilation requirements.
There's always a bit of a headache in how we dealt with things in different municipalities that did have radon. So, unfortunately, of the 4 courses that TECA teaches, this is the only one that's actually about the building code. The other 4 courses are, although they are fantastic courses, are not required. This is required by anyone doing heating and ventilation residentially. This certification program and passing this course is required to do ventilation systems residentially in BC. Not all municipalities enforce it, but most of them do now. And it is unfortunate because the fact is that there's no meaningful building code regarding heating systems in BC. And for that matter, there's no meaningful requirement for how do I put it? No meaningful requirements about who can install a heating system in BC. That's an unfortunate fact. Something that Tech has been working on for many, many years to try and bring some type of code wording to improve or to make a requirement for someone to do a heating system to actually have some training to do that system. So right now it's buyer beware. So why do we mechanically ventilate? Why do we require mechanical ventilation in a home? People stink. Yeah, they also give off carbon dioxide, about 20 cubic feet per person per day. And we give off moisture, about a quart of water per person per day, and then another quart cooking and taking showers and doing laundry, what have you. But the primary reason is people stink. Well, my primary reason would be. And the amount you stink has actually been quantified in these little snowmen there. They're called olfs, and the average person gives off 1 olf just standing there. And that's the average person. I probably give off a few more because I smoke. You can see at the bottom, the page, smokers produce about 5 to 7 olfs. And then your activities, using the toilet and cooking, anywhere 3 to 7 olfs, and that air has to be ventilated. And don't think this is a new phenomenon. People have always stunk. People have always given off moisture. People have always given off carbon dioxide. You know, in 1990, as I said, I built an certified R2000 home, and yes, it was certified R2000 home, not a copy, this is actually a registered R2000 home. And I learned a lot from that. And later on, that house was also registered under the Enter Guide for Housing program. They even had to have a blower door test, the dreaded blower door test. You know, it's not that big a deal. I actually failed the first time, and for a few $100, while they were doing the blower door test, I went around and found out where I leaked, and I learned a lot. And for a few $100, I sealed it up, and I passed on the second time. And then about 5 years later, they did another blower door test, because at that time the federal government was testing homes all across Canada, that certified R2000 homes, testing them for air quality, testing them on how well the air tightness has held up over that time, and the house passed with flying colors on both counts. And then I did a fourth one to register under the Enter Guide for Housing. Like I said, this blower door test, that I know there's a lot of fear and trepidation amongst the builders out there about it. It's no big deal. You just got to get used to it. You just got to understand where buildings leak and deal with it at the time. But for 26 years, as I said, I lived and raised my family in that home with high efficiency appliances and continuous ventilation. I sold that house a year ago, and I moved to a 1935 home in Victoria. I miss my R2000 house. It was comfortable, it was quiet, the heating was even, and the air quality was very, very good. And this 1935 house, it bothers me. I'm going to have to do some work on it to bring it up to my standards. So this conception that older homes are built better or ventilated better, it's bullshit. The new codes and the new requirements for ventilation far improve the air quality, far improve the life of the people living in those homes. We are building better today. Anyway, I'm going to get off my soapbox. So today I just wanted to give you a brief overview of the changes that have happened over the last few years in the building code as far as 9.32. Also wanted to go over and actually give you basically a Reader's Digest version of what the ventilation contractors have to do, the course they have to take to be certified to install these systems. So the initial changes, the overarching changes, is fresh air distribution to bedrooms, as I said, is now required. Operation of the principal system must be continuous. No more timers, no more dehumidistats. And further, permitted secondary suite will also require a continuous operating system meeting the same distribution requirements as that required of the principal dwelling unit. I kind of went over why we do that. That's at the bottom of that rationale. We also changed, in 2012, with the advent of 2012 ventilation code, we did change the method of calculating the size of the principal fan. That's your ventilation fan, the fan that runs continuously. In the past, we strictly used bedroom count as a means of determining how many people were living in the home, because in BC we ventilate for the people living in that dwelling. We don't ventilate for the dwelling. We don't ventilate for people who want to finish furniture in their basement. And we're strictly ventilating for normal living conditions. The risk that you take by trying to compensate for formaldehydes in furniture, formaldehydes in carpets, is that many people aren't going to have that, and you're going to over-ventilate that home, causing higher heating bills and a more uncomfortable home. And in colder climates, excessive drying of that home. So we want to keep that ventilation rate good enough. We want to keep a bit of fudge factor in there, but we want to focus on the occupants of that home and just normal living. So the change that went from before was strictly just bedroom count is now we did take into account the volume, the interior volume of that home. So there's actually a cross graph between the square footage of the home and the number of occupants, because obviously the more occupants in a smaller home, it's going to be more of a problem than fewer occupants in a larger home. So there is a cross-reference graph in the code that deals with that. But the most significant change in the code was to require that all bedrooms have air exchange, and I get into that earlier. The secondary exhaust, bathroom fans remain the same, 20 CFM if continuous, 50 CFM if it's on a switch or a timer. They did bump up the kitchen exhaust rate from 80 to 100 CFM, pretty minor. I think the consensus on the committee was that I've actually never seen a 100 CFM kitchen fan. I think the smallest you can buy is about 150, 180. But I think that was a small, and that's strictly used on an intermittent basis anyway. Crawl space ventilation, maybe get into that a little bit more. There, if it's heated crawl space, we do a little bit later actually. There are different methods of ventilating heated crawl spaces. And I've done heat losses for 30 years in my career, probably weekly in heat loss calculations, and I can attest to you that you're always better off heating a crawl space than not heating it. A heated crawl space uses less energy. A house with a heated crawl space uses less energy than a home with an unheated crawl space under it. You've got one more side of the home to lose heat from. And the crawl spaces are healthier environments if they're heated. So, in my opinion, you should treat a crawl space like a very short basement. You insulate the perimeter and you ventilate it as part of the dwelling of the home, and you heat it. And that's been the consensus of the new code. There were some changes in the way we calculate the sizing of ductwork for the all exhaust fans in the home, all ventilation fans in the home. Before it was just set, it was this CFM, it had to be this size. Whether this size if it was rigid and this size if it was flex duct. Now there's a cross-reference table that shows you, depending on how far you're going with that ductwork, you can actually, in a lot of cases, stick with a 4-inch duct. You can't use 3-inch, by the way. I can't believe how many people come to Echo and buy 3-inch ductwork, or ask for it. We don't even stock it. But some fans you buy have 3-inch outlets. I even have people using 3-inch ductwork on kitchen fans. Yeah, because that's the hood that's on the outside of the wall. It won't work. You might as well not bother ducting it. It's just going to sit there and make noise. This is just going over what I've kind of. This is the actual wording in the code. This is straight out of 9.32 of the BC Building Code. Basically, just confirming what I've already kind of gone through. Secondary suites, heated crawl space. We do include a little bit about 9.36 in our certification course for 9.32, partially is to kind of get rid of a bit of confusion regarding insulating ductwork. And I know you guys have come across this with ductwork that's in attics, and depending on what your zone you're in, basically the rule is that the insulation of the ductwork in an unheated space has to be the equivalent of the exterior wall of that building, depending on what zone you're in. So if you're in zone 4, it's R20 roughly in your outside walls. Any ductwork traveling through unconditioned space would have to have R20 around it, and that can cause some real grief. But in fact, the ductwork, most of the ductwork that you use in section 9.32 is ventilation ductwork. So it's taking air into the house, fresher, cold air from the outside into the house, and it's taking stale exhaust air, and you're taking that out of the house. We're not concerned about losing heat either way. So in fact, that insulation requirement never changed. So in terms of an exhaust duct that is located or adjacent to a not conditioned space, that ductwork should be insulated to R4. And that could be simple fiberglass insulation. It does not have to have a vapor barrier, because your vapor barrier is always on the warm side of your system. So the ductwork itself is your vapor barrier. And this is not always clear with inspectors, so I apologize if you get grief from inspectors on this, but you could simply take fiberglass and strap it around that ductwork, R4 fiberglass. But when you're taking fresh air from the outside, and where that fresh air duct passes through conditioned space, there you need R4 as well. Not R20, just R4. But it has to have the vapor barrier on the exterior of that insulation, on the outside, because we want to prevent that warm, moist air from hitting that cold duct. Obvious? If you don't want stains along your basement ceiling, you have to both insulate it and vapor barrier it. If you insulate it and don't vapor barrier it, you're just going to end up with a big pile of soggy insulation. So you have to have that vapor barrier always on the outside for cold air that's entering a home. So that was why we brought that 9.36 section into this certification course, just to bring that point up. The most important thing I want my students to come away with after taking this course is to understanding the difference between a naturally aspirated fuel-fired vented appliance and one that is not. Because we're ventilating in a home, sort of like the doctor's creed, do no harm. Because you're ventilating, a lot of ventilation systems are a negative pressure system. There is a risk when you have a naturally fuel-fired vented appliance. That's a long way of saying an appliance that has a chimney. If that appliance has a chimney, whether it's a B vent, whether it's an A vent, or a C vent, if it's relying on the thermal buoyancy, in other words, the inefficiency of that appliance, the heat that's left over, it's relying on that heat to create a draft and exhaust that combusted air, that smoke, if you will, out of the building. The word natural kind of would give you a clue. We're relying on nature. And nature doesn't always do what you want it to do. And if you put the building under enough significant negative pressure, you're running the risk of pulling those products of combustion back into the home and actually doing harm to the residents of that home. A non-NAFA, on the other hand, is a sealed combustion and or power vented appliance, like a direct vent fireplace. All gas furnaces sold today in BC are high efficiency, condensing, power vented, non-NAFA appliances. You still see draft hooded hot water tanks, and NAFA hot water tanks. You still see NAFA boilers on the market. But a lot of the fireplaces are going to direct vent anyway. There's an example where the things weren't the right combination of ventilation, and NAFA appliances were not considered. So like I said, a naturally aspirated fuel-fired appliance is relying on a natural draft. So a large negative pressure, say from a kitchen fan, can actually cause that product to back vent and spill products of combustion back into the house, doing the occupants harm. Here's some examples of non-NAFA appliances, or high efficiency. You can always tell if the appliance can be vented with plastic, you know it has to be power vented. It can't, in its nature, it can't rely on thermal buoyancy because the plastic couldn't handle the temperatures of the heat of that exhaust. Here's some NAFA appliances. You can always tell where the arrows there are. Those are showing chimneys and draft hoods. You can see there's draft hoods there. That's where generally the products of combustion would be pulled back into the home if that house was put under enough negative pressure. And not just the house, sometimes it's just the room itself because of an improperly ducted or improperly sealed heating system, where a hot water tank is in a room with a furnace where the furnace return air ductwork was not sealed properly. That room can get put under significant negative pressure and cause, say, a hot water tank, for example, to spill back into the house. Mid-efficiency furnaces really, I suppose you see them around still if you're doing renovations. You can't buy them in BC, and you haven't been able to for about 10 years now. But a mid-efficiency furnace, even though it's got what they call a draft inducer, it still requires a chimney to vent, and it still requires thermal buoyancy to draft it. So it actually is a NAFA, and there is a risk where that mid-efficiency furnace will usually downdraft and come back into the home is actually down the hot water tank vent. That's usually typically on the same B vent. Of course, we talked about direct vent gas fireplaces. They, are, by their nature, are non-NAFA. Even though they're not power vented, they are sealed combustion. They are taking 100% of their air for combustion from outside. They are not affecting, and they are not affected by house pressures. And that's the idea. You can always tell a direct vent appliance is one that you can legally sidewall vent. Not that you have to sidewall vent it, you can vent into the roof, but if you can legally sidewall vent that appliance, it is non-NAFA and safe to use. But if it requires a chimney that has to be above the roof line to work, it is usually a NAFA. There is one exception with wood burning, and this only applies to mobile home approved wood burning appliances, wood stoves, and they have to be installed to mobile home standards. I mean, mobile homes have been going through the issues that we're dealing with today for many, many years because they're built very, very tight. And so these issues have been dealt with a long time ago with mobile homes. So if that wood stove is mobile home approved and is installed to mobile home approved standards, it would be considered non-NAFA and would not become an issue to you. So just to start the little mini course. System 1, we developed forms that the installers would fill out and hand to the municipalities. So in the process, you couldn't use just one form because there's so many different systems. So we developed 4 different forms, depending on the system that's being installed in the home. So what we call number 1 system would be forced air heating system. I don't really agree with the word heating, but that's the way it's written in the code. It's actually any forced air system. It could be an air conditioning system. You could use this Form 1 for that. Basically, it's a system it's a fully ducted circulation system throughout the whole house. So every room's got either air in or air out through that recirculation system. So forced air heating system, what we would then do is pick our principal fan, and we would go to the code tables to do that. I don't know if you've showed that here. I can flip forward to a code table, but it's several pages down. We'll go over that later. So the principal fan you would size according to the number of occupants or number of bedrooms in the home, and a combination of that and the square footage would determine the size of that principal fan. And that principal fan would then be set to run continuously. Then you have 2 choices in the tree. You can use just a simple bathroom fan. You don't have to go out and buy anything exotic. You can use a bathroom fan, but it's got to be quiet. It can't be louder than 1 zone. Because we want to run that continuous. We don't want we really ideally don't even want the homeowner not even to know that it's there. That it's just quietly and continuously keeping that house fresh for the occupants. So your options are to use that, just like I said, a ceiling mounted bathroom fan. Or you could use what we call a CEV, and you'll see on the bottom right hand side, central exhaust ventilator, and that's where you use one exhaust fan that's then ducted to maybe several bathrooms possibly, but you have that centrally located exhaust fan, and again, that's set to run continuously. But it still has to be sized to meet the capacity required as a principal fan. Now, how do we make up air for that exhaust fan? We're exhausting air out of the house, and every cup of air that's taken out of a house, a cup of air has to come back in. That's just physics. So we want to try to control where that air is coming back into the home. So what we do is we bring a 4-inch rigid or 5-inch flex duct from outside and connect it to the recirculating furnace system. Whether it's forced air heating or whether it's an air conditioning system, as long as but that fan there on that circulation system also has to be set to run continuously. Now there is a little bit of a rule on where this fresh air comes. It obviously comes in to the return air side of that circulation system, but there is a rule about where it's connected. It cannot be more than 15 feet from the fan, and it can't be less than 10 feet from the fan. Probably ask you guys why that is, but you might not know. If you connect it too close to the fan, I mean, because you've taken the other TECA courses, you know how to size your ductwork properly. So in theory, if you bring that in the return air side of a forced air system, once you get more than 10 feet, is really under no pressure at all. It's strictly a path for the air to get back to the furnace. But as you get closer to that blower, there is more and more negative pressure exerted, and what would happen is you'd be bringing in more fresh air than you wanted, or possibly. And there is a theory with some manufacturers that could be, in cold climates, that air could be coming in too cold. It wouldn't have enough time to mix with the return air and actually do damage to the heat exchanger of that appliance. That really hasn't been found to be true, but we kind of decided to be a little bit more conservative. But the main reason is that we want time for that fresh air to mix with your other circulating air, so that by the time it comes out of the fan, it's really unnoticeable, the temperature change. It's virtually unnoticeable. The 15-foot rule is that once you get far enough away from the furnace, what would happen is there's not enough pressure there to actually cause any mixing at all, and you would have that cold air just coming out the very first return air grill and not getting mixed with the circulation air properly. At least that's the way I think. That's the way I thought about it. But again, that fan must be set to run continuously along with your principal fan or your central exhaust ventilator. I mean, it's pretty simple stuff. In fact, I think it's simpler than it used to be. In the old days, using timers and dehumidistats, which were kind of ineffectual. But one thing I want to say about this, if you're going to use this bathroom fan as your principal fan, it does have to have a service switch by electrical code. It has to have a switch to turn it off, but I would recommend that you keep that switch in an area that's not obvious, like either in the mechanical room or high wall in a closet, because we don't want an uninformed homeowner to be able to turn that fan off inadvertently. So although we don't use dehumidistats or timers, we do need that service switch. Any questions about that so far?
Obviously, the breaker doesn't satisfy that requirement.
I don't believe so. I think it has to be within a certain distance of the appliance.
Electrical code says you gotta be within 15 feet. The disconnect that Terry referred to for electrical safety is actually built into the fact that the fan motor has its own plug. So that's where you comply with electrical safety for the serviceman working on it. The BC building code, however, does say you need a separate switch, as Terry said, in the mechanical room, and I believe it has to be labeled with the word ventilation fan or something, there's some
So
actual legal wording.
So in actual fact, it could be the breaker. It could be on the breaker panel then. So,
Well, if I was building, I wouldn't pay for one circuit for one fan when it's a 50-watt load.
Electrical code says that any switch or device that has to turn off by a switch has to be so where you can actually see the device. So if you're having a fan, you actually have to have a switch so you can actually see the device.
okay.
The building code states that for the principal exhaust fan, you have to have a switch that can be turned on and off. It has two positions, on and off. It has to be placed for maintenance purposes somewhere where it cannot inadvertently be turned off, and labeled principal exhaust fan switch.
Okay.
So you're actually, the BC building code somewhat conflicts with the electrical code. Because if you put it in a closet, so it can't be inadvertently turned off, the electrical code says you have to be able to see the device.
So your electrical code's always complied with, because if you remove the fan cover, the motor actually has its own built-in, factory built-in disconnect for service.
Yeah,
All cabinets have a plug and unplug.
They all have that.
all bathroom fans have that.
Have that now?
Yeah. So they can be anyone can replace it simply by unplugging it like a toaster.
A plug-and-play change-up.
Yeah. All right. Any other questions about that? If not, the last below that dotted line. Oh, by the way, maybe just to jump back a little bit, that principal fan, whether it's this one or this one, could be a 2-speed fan. You could, and I think that's a really smart way to do it, where you have a single fan that has a high and a low switch, so that you would have a switch in the bathroom to turn that fan up to high when you wanted it to, but when you turn that switch off, it would run on a continuous low. As long as that low met our requirements for the number of occupants in that home. And many manufacturers, or most manufacturers of bathroom fans, do have some really nice 2-speed fans available. Yeah, they're a little bit more money, but I think you're doing a good service to the homeowner. Now, below this dotted line has to do with a different part of the code. Right now, up to this point, we're just dealing with the occupants of that home. Below that dotted line has to do with certain exhaust requirements of certain rooms under certain conditions. So this has nothing to do with the principal fan. This is in addition to the principal fan. Every kitchen must have an exhaust fan vented to the outdoors. I know you can buy recirculating hood fans at Home Depot, and some of the passive houses are getting away with it. I think they're having engineer sign off on it. But every kitchen fan by BC Building Code, must have an exhaust fan that's ducted directly to the outdoors. And it must be a minimum of 100 CFM, although again, I've never seen one that low. I suppose it's possible. And it's strictly on an intermittent switch, so not to be set to run continuous. With bathroom exhaust fans, the minimum is 20 if they're set to run continuous, 20 CFM, or if it's on an intermittent basis, it's 50 CFM minimum. Every bathroom, and that includes powder rooms, must have an exhaust fan. And that's been true for 20 years now. One of the things that was cleared up, made really more defined in the 2012 version of the BC Building Code, there was a lot of confusion prior to that on whether this principal fan could also be used as your bathroom fan. And I think now it's more defined, and it's made it very clear that yes, that one fan can serve both functions, as long as it meets both portions of that code above and below that dotted line. I know some municipalities are getting really confused about that and requiring a separate principal fan. And there's nothing that says you can't have a separate principal fan, but you don't have to.
I think people tend to underestimate the power and effectiveness of that simple system. It really, really works well.
Which reminds me to bring up that principal fan by code can be put anywhere in the home. There is no requirement in terms of what room it has to be in. That's really up to you and your heating and ventilation contractor to determine on the best location for that particular home. The code is silent on that location. It can be in a hallway. It can be in a closet. It can be in any of the bathrooms in that home. Any questions about this system 1? Because the rest of them actually get easier after this. They're different, but they're simpler. I mean, this is actually a very simple system and probably a system I would like to see used more commonly. I would really like to see, and this is personal opinion, this is Terry Regier's opinion, I'd really like to see a drift away from this wave of houses going to electric baseboard heat. I just think you're doing your homeowners a huge disservice. But I know costs come into play. But once you start looking at the advantages of using this type of system, not necessarily a forced air system, but a recirculation system, and the fact that you do have to ventilate or have air changes in every bedroom, I don't think the costs are that far apart between totally electric baseboard house and one that uses some kind of air system. Number 2 system is HRVs. Ventilation codes are written to be a minimum, and to be enforceable, they have to be somewhat prescriptive. So, but that doesn't mean you can't go beyond the building code. And again, contrary to common belief, other than the city of Vancouver, HRVs are not required in BC. I don't think any other jurisdiction requires HRVs, unless it's something to do with meeting the energy code in certain zones, and they decide to use an HRV to meet that step. But other than that, there is no requirement for HRVs in BC. So the first thing we're going to do is we're going to size the HRV, and this is a question at Echo Heating I get called constantly from contractors, from ventilation contractors. Terry, I need an HRV. I says, okay. Well, how big do I need one? And they'll start telling me the square footage and everything in the house. I said, wait a minute, how many bedrooms? How many people are living in that house? Well, it doesn't matter, 7,000 square feet. Yes, it does matter. If there's only 2 bedrooms and it's a 7,000 square foot home, your ventilation rate isn't that much different than if the house is 2,000 square feet and a 2-bedroom home. So I tend to think that there's a lot of oversizing of HRVs in this industry for the wrong reasons. We're going to size that HRV exactly like we did before, based on the number of occupants in the home. And we'll go through the tables in a bit and I'll show you it's not really that high a CFM. And again, it's going to be set to run continuous. And most HRVs have 2 or 3 speeds to them. I'd recommend that the HRV did meet that continuous rate at its low speed and still had the ability to turn it higher if the homeowner wanted to or needed to. I'm not going to get too much into duct sizing. I don't think that's really relevant to the audience, but all ductwork must be sized according to the tables as well. But because an HRV is fan-driven, again, there's 2 methods that it can be distributed. One is that you could have the fresh air from outside and dump it into the return air of some type of recirculation system, just like in the previous sample 1. Because it's fan-driven, it doesn't matter where that air comes in. Now we're not worried about it, and because it's tempered by the heat recovery unit, we're not worried about where that's coming into that duct. It really can come in anywhere. But the exhaust side of that HRV must come out, must have one exhaust wall or ceiling height on the uppermost level. So the days of bringing both these ducts into the return air side of the circulation system are gone. It's not allowed. The exhaust ductwork must be run independently. And then the other example is have a totally non-integrated system where the HRV is just doing its own thing, and there again we have to have one or more wall or ceiling exhaust points at the uppermost level, and we're going to provide fresh air to basically every area that we're not exhausting. Again, every bedroom, and at least one in one in the living area of each floor. The ductwork is up to the right now until TECA comes out with their HRV course. The ductwork would be sized according to the manufacturer's recommendations, but again, I don't think we need to get into too much of that today. If you are going to integrate it with the recirculation system, a forced air system, a forced air heating system, this fan must also be set to run continuously. If you do it independently, it doesn't matter what this fan's doing. The bottom part is exactly as before. That doesn't change. System 3 are CRVs. Central recirculating, I know there's a lot of acronyms, not just in this industry. I don't know if you've been on any government committees, but you need an interpreter. There's so many acronyms, but CRVs, Central Recirculating Ventilator. And then when you think about that, the fan is central, and it's recirculating. And it's bringing in fresh air from outside, a 4 or 5 inch pipe from outside, and it's bringing a little bit and mixing it with the air that's being exhausted or supplied to the house. And you can do it either way. You can use your CRV to exhaust the bedrooms and dump into the living area of the home, or you can take the air from the living area of the home and dump it into the bedrooms. Basically, it's just a mini furnace or a mini forced air system. When this came up, when we were developing this form, I didn't think anybody would use this. And it doesn't make sense to me, but apparently it's one of the most common systems used today. I don't know what your guys' experience is. Builders keeping with the baseboard heat and putting in the CRV.
Part of the heat exchanger?
Nope. No, but the difference is that what does change depending on your climate, because what we're doing is we're relying on this air, circulating air, to temper this fresh air coming in from outside when it's cold. So what the rule is, when you get into colder climates, we have to put a larger fan in. So we're circulating at a higher rate, causing more mixing of that fresh air coming in. So in a coastal climate, the CRV is going to be 2 times larger than your principal fan. But in cold climates, that CRV must be 3 times larger than your principal fan. So for example, that your principal fan, just to make it simple, had to be 100 CFM. In a coastal climate, you would have to be a minimum of, the CRV would have to be a minimum of 200 CFM. But in colder climates, that CRV would have to be 300 CFM. It could give you more mixing of that cold air, more of a chance for that air to warm up before it entered the home. Again, we're just going to use your regular principal ventilation fan, and that's either like a bathroom fan type of exhaust, or you could actually use a CEV. You could use a CEV and a CRV. Basically, you installed an HRV without the heat recovery portion of it, which seems a little ludicrous to me, but you could by code. But generally speaking, you're going to have your bathroom fan size to meet the building code in terms of the occupancy level of the home. That would be running continuously. And then this fan would also be set to run continuously. And there again, it's probably a good idea. You could use a 2-speed circulator, but I don't know why. No, you couldn't. I'm wrong about that. I was thinking about the other fan, the other CEV. Never mind. Move along. And again, we can either supply to the common area or return from bedrooms, or supply to bedrooms and return from common area. Either way, whatever makes sense to you. Any questions about that? Because it's really... And then the bottom part, again, doesn't change. You still need a kitchen fan, you still need bathroom fans. Maybe just to jump back a little bit to this one, it is possible under the code, and it's completely viable way is to use the HRV not only as your principal fan, but it also could be used as your bathroom fan. You don't need to put additional bathroom fans in this system. You could use it to do both functions, but that's a little thing to talk about with your ventilation contractor. And finally, we got small dwellings. And when this was originally developed, we were thinking in terms of MURBs, high rises. There was a talk at the time that they were going to include vertical multifamily units into the 9.32. They were going to draw it into there, but that unfortunately didn't happen. And that's when we first started working on that. It was specifically for those. But it actually had a really nice fit into those secondary suites, those basement suites. And but the rule is on this system, it can only be used in a relatively warm climate where the winter design temperature is not lower than -4 Fahrenheit. And the dwelling unit can't be more than 1,800 square feet. And it can only be one level. I know that gets a little bit weird with these carriage houses and backyard homes, or laneway houses, because you're actually entering from below. At what point does it become a one level, or at what point it becomes a 2 level? All you're doing is going up a staircase. I would think that'd be 1 level, but a lot of these have a laundry room down there, and they may not apply to this system. You may have to go back to 1, 2, or 3 for them. Have you done a lot of laneway homes? No. It's real common in Vancouver. Have you seen what they do there?
It's always been a contentious question, Terry, and there's no clean answer. How much more than an entrance do you have to have before technically it becomes a 2-level dwelling unit is the question that is raised. Okay.
Again, we're going to size our principal fan exactly the same way as before by bedroom count. But in addition, what we're going to do now is we're strictly going to have passive air inlets. And it must be at least 4 square inches of free area. And we're going to bring that fresh air directly in to each bedroom and 1 to each common area. So in this case, it's showing a 3-bedroom dwelling. There's actually 4 inlets, and that's where the air would come in to replace the air that we're exhausting from our principal fan. These outlets must be a minimum of 6 feet off the floor, and they're supposed to remain open at all times. Now, this system is actually the most, David, correct me if I'm wrong, but I think this is the most common ventilation system used in Europe and has been for about 50 years. In fact, in Europe, you can buy windows with a permanent vent in them already there for use for this system. And they've been used to small square footages and high occupancy for a long time. Unfortunately, you can't sell those windows in Canada because it doesn't meet the energy code. It contravenes the energy code to have those slots in those windows. But so generally speaking, these slots are done with ductwork There are some very sophisticated air inlets that you can get that are imported from France and Germany. They are available. I know Panasonic makes a really nice one, but it doesn't. The code doesn't really say how to do it. It's just that it says where you have to do it, and it must be at least 4 square inches. As we get down to the bottom, I'm not even going to go into that non-heating season requirement. It's beyond me. I think this bottom section, I don't think I'll talk about it. What do you think?
We've asked for guidance, both provincially and nationally, on that one, and we've never got any response. And the historical reason why that's in the code, it's been there for 30 years, and
Nobody can remember why it was put there.
why it's there.
Yeah. Anyway,
That
so we.
deals with the den in a townhouse which has no window, and it's not a bedroom, and it deals with the bunker underneath the garage. And those numbers have no defense, no logic, and they've been in code for so long, everyone died off and wrote it.
Yeah, the only defense I would make, and then what this has to do with it, is a room with has no openable window. You know, and where I've seen this in the real world is those bunkers that end up underneath the garage that are out totally in ground, and then people say, "Hey, this is a perfect media room." That's where this code can really probably have some effect, because those rooms are very tight, high occupancy with a lot of equipment in them. They'll get hot really fast, and I think that and stuffy and I think maybe that's where you'd want to pay attention to this part of the code, but I won't talk about it anymore. Kitchen exhaust and bathroom exhaust, that doesn't change. So those are the 4 systems that we have forms for. And here's the code tables. So as we look at this graph, it goes less than 1,500 square feet. One bedroom, we need a minimum of 30 CFM. If that house has 2 to 3 bedrooms, we need 45, 60, etc. To the very end where we got houses that are over 7,500 square feet, and we stop there because at that point there's so much volume in that house that the occupancy level is not having that much effect on the air quality. But we stopped basically at 155 CFM requirements. So this is the table that you'd use to decide on the size of your principal fan, whether that be a bathroom exhaust fan, or whether that be an HRV, or a central exhaust ventilator. Bedroom, we talked about the bathroom count, and this is about the duct sizing, and it's probably not something you guys really need to know, but your ventilation contractor does need to follow these guidelines for the ductwork for all exhaust fans in the home. This is just, and these are right out of the code. These tables are in the BC Building Code. Code requirements for air ducts. This is the insulation requirements under 9.32. And again, in our book, we do go over 9.36 a little bit. Crawl space ventilation. There's 3 methods of ventilating a non-forced air heated crawl space. There's basically only one method of ventilating a heated forced air heated crawl space. I think we're getting close to our time limit here, so I just wanted to touch on this one because I know this is a contentious issue for builders. When do you require makeup air for other exhaust appliances? The only time in the BC Building Code you require a makeup air system is if, one, that exhaust appliance is over half an air change per hour based on the interior heated volume of that house. So the ventilation contractor has to calculate the entire heated volume of that home. Now this is where you include crawl spaces, storage areas. As long as it's part of the heated volume, he has to calculate that volume, times it by 0.5, and did I get that right? Times it by 0.5 divided by 60, right?
I think so.
Why 60 times by 0.5?
Yeah. So, and half an air change per hour is that critical number. Over the years, it's determined that that's the amount, that's that critical point where you're creating enough negative pressure to cause any naphtha appliances to start spilling into the home. It's that, what is it? I'm having a brain fart. 5 pascals?
That was the threshold.
Yeah, 5 pascals is what, at 5 pascals negative pressure, the draft hood will start to spill the products of combustion back into the house. So as we go down this flow tree, you're going to determine the house volume first of all, and then you're going to determine, and that line right on shouldn't be there. That's our map. This light went out above me. Anyway, God. The house volume is going to determine your half an air change per hour, and then whether there's a naphtha present or no naphtha. The radon issue, that should be erased. Scribble that out. That has been taken out. This is just an old slide. So if there's no naphtha, no makeup air is required. And I get this asked all the time. I need a makeup air system. Well, the first question I ask, is there any naphtha? Well, what's a naphtha? Was there any chimneys?
Terry, can you dwell on this? I also get more questions this than anything else in the BC Building Code. Is everyone here satisfied you know what Terry just said? It's really, really important because the majority of the builders out there are asking Terry these kind of questions. So
Well,
I like it when you leave here that you are absolutely confident in your mind when it is and when it's not required.
I get the feeling, I get the impression that it's not just builders, it's homeowners and it's ventilation and heating contractors are under the impression that we need makeup air to make this fan work properly. And it's not true. That fan is going to move whatever air, as long as it's ducted properly and ducted to code, that fan is going to move whatever it's designed to move. It's going to find its air somewhere. And again, I lived in an R2000 home. These are very, very tight homes. And my exhaust fan never suffered for it. It got the air from somewhere. It's going to get it around the cracks, because even by the way, when you do a blower door test, they can tell you what your equivalent leakage area is. And my house is 2,400 square feet on a crawl. And the entire equivalent leakage area, they added up all the leaks, was an 8 by 8 hole. And that's a very tight house. There's houses they tested under the, in the city of Vancouver, because they have been requiring blower door tests there for a long time. But they don't require you to meet a standard. They just require that you do it. And I've talked to the guys that do that test, and there's houses, brand new houses, where when they do the blower door test, and these are 3,000 CFM exhaust fans and higher, where the needle didn't move. In other words, it was that leaky. That fan was getting no resistance in pulling air from outside. And that's pretty bad. That's not very good for the homeowner. Getting back to this, though, the makeup air system is not there to make this fan perform any better. What the makeup air fan is there to do is to prevent this fan from killing the occupants of the home. To be blunt, this fan from bringing smoke back into the house. And the questions that have come up before, and I don't want to go too far down this rabbit trail, but when this became a requirement, was that 20 years ago? We brought the mechanical makeup air?
1987. Mark your socks. 30 years ago.
30 years ago. And I think it was Steve Gertzman was head of the committee at the time, and in the previous versions of the ventilation code, they started requiring for larger kitchen fans, they started requiring a 6-inch pipe from the outdoors into the kitchen area, thinking that would do it. And Steve Gerson was chief building inspector for the city of Delta, or I guess it was district of Delta at that time. And he was getting problems. He was getting houses where the kitchen fan was back venting the fireplaces. And then back then there was still a lot of wood burning fireplaces being installed. Not so much anymore, at least not Lower Mainline. So they went over to, went to this test house that they were working on where they're having this problem. By the way, that fresh air intake, everyone thought was really good. We'll bring it up behind the fridge, because the heat exchanger back on the fridge, on the back of that fridge, will then temper that air before it enters the house. Two problems happened. Ones that did have heat exchangers in the back of the fridge died a slow death. And most new fridges, you can't buy a fridge today where the heat exchanger is actually exposed on the side of the house. It's all encased and has a little fan that it takes the heat away. Anyway, so that didn't work, but the 6-inch makeup air obviously wasn't enough for this particular house. And this is one of those this is showing how long ago. This is the Regier downdraft. The beautiful griddle kitchen that didn't work, but it did exhaust very well. It just didn't exhaust the smoke that you're producing off the range. But it was a Regier, I think at that time they were called 400 CFM, or it might have been 600 CFM exhaust fan. Whenever that fan was on, the smoke came out of the fireplace in the fan room. So Steve and a few other guys were there going, okay, obviously the 6-inch hole in the kitchen wall or floor or whatever isn't enough to replace this air that this kitchen fan's exhausting. How much passive air do we need? So they went over to the patio door in the same room, and it wasn't until that patio door was fully open that fireplace started venting properly. Obviously, that's not practical. We're not going to be forcing people to open their patio doors. Maybe we could put an electric motor on every patio door. Whenever they use their kitchen fan, the patio door would open. It's not going to work. So at that point, it was decided that we need mechanical makeup air for these large exhaust fans, but only in homes where there's NAFA appliances, only where there's a risk. Again, because it's not there to make that one work properly, it's there to make sure all your fireplaces are still venting and your hot water tanks. Now, in every municipality in BC, not only do we have to have mechanical makeup air, and that fan has to be of equal capacity to your exhaust fan, but it also has to be reheated. Let's step back a bit. First of all, that fan has to be greater than half an air change per hour installed capacity, and I'll get into that a little bit if I've got time. What does installed capacity mean? If it's less than half an air change per hour, no makeup air is required. So again, that's that important calculation of calculating the interior volume of that home. But that air, when it comes, so then if it's greater than half an air change per hour, we need mechanical makeup air, and that mechanical makeup air must be interconnected. Commercial, you would interlock. You can't do that residentially. It has to be interconnected. In other words, they can't be hardwired together. There has to be a passive connection between the two. So whenever this exhaust fan's on, this fan will bring fresh air into the house. But we don't want to freeze the occupants, so we're going to have to put a reheat coil on that system, and that's done typically electrically. Not necessarily, but usually that's done electrically. And that air, when it reaches the occupied area of that home, and that air actually has to have a path to get back to this fan from, so it can't be in a separate room with a closable door. If it is, it needs a series of transfer grills so that air can get back to this fan. Houses will compartmentalize. We have to make sure that the compartmentalization does not penalize this makeup air fan, that this air can get back to this appliance. But then it'll have to be reheated. And there's a very easy calculation to determine how much heat you need depending on where that house is, depending on what CFM you're bringing in.
Terry, if you go down this path, how much should a builder realistically look for the cost of that makeup air system?
Well, I was a heating contractor for many, many years. I haven't been since,
Yeah, you're old now.
yeah, I think I've been in the wholesale side for 15 years now. But 15 years ago, I didn't do this for less than $2,500. Just this system here. And that was 15 years ago. So it's messy, it's complicated, and it can all go away by going to non-NAFA. And I used to scream till I was blue in the face with the builders and the homeowners. It's just, if you didn't put that draft-hooded boiler and went to a high-efficiency boiler, yeah, they're more money. But take the $2,500 you're going to pay me, put it towards that boiler, and it's win-win. But if you go to that, you have to use that low-mass draft-hooded boiler, I'm going to charge you $2,500 or more for makeup air. This gets really messy. And one of the reasons it gets messy, even messier, is the fact that this word about installed capacity. All bathroom fans sold in BC are independently tested. Every bathroom fan on the market, they're independently tested for CFM, for noise, and now for Energy Star rating. That's a requirement in Canada, I think. Unfortunately, there is no such requirement for kitchen exhaust fans. Don't ask me why. And it virtually comes down to the manufacturer of that kitchen exhaust fan to basically say almost whatever they want. And many of these fans I've tested over the last 30 years, where we've actually checked their CFM, they're not even close. They may be, I've seen them as low as a third of what their advertised rate is. 900 CFM fan is 290 CFM when tested. I don't know where they get these numbers from. I'm not saying they're lying. I hope they're not lying. But the 600 CFM fan, most everyone I've tested, 250 maybe in terms of installed capacity. So what I'm getting at is that be careful sizing this fan, because if you come to Echo Heating and say, I need a makeup air fan, and I'm going to say, what size is your exhaust fan? Well, the brochure says 900 CFM. I'm going to give you 900 CFM. And we're going to end up pressurizing the house. And we're not doing any favors to the homeowner here. We're actually costing a lot of energy. When in fact, this fan's only running at 260 CFM. And I'm providing 900. You can see where it gets a little messy. It's unfortunate that and then to complicate that or compound that, these exhaust fans are sold by the appliance salespeople. I've never had an appliance salespeople take my course. And even I had to buy an exhaust fan for my house in Oak Bay, kitchen exhaust fan. Oh, you don't want this one. This one's way more CFM. He had no idea why that was a good thing. Well, this will really do a much better job. I didn't have the heart to start jumping on him and telling him who I was, but I just let him go on, carry on. But anyway, it's very, very common with homeowners. They get convinced to put in larger fans. In fact, I went through that conversation just last week with a homeowner wanting to know why she needed makeup air. And I said, well, it's because the kitchen fan you're putting is too big. He says, well, that's the one the appliance guy said to use. Go ahead.
In the manual, we've now assumed that if you get a color brochure quote for 1,000, you assume 60% of it.
Right.
Do you think that's still realistic, or should we be revising that?
No, I think 60 CFM is a nice number. I mean, it's conservative. We're probably still hitting it a little high, but I mean, there are some fans that perform better than others. Some kitchen fans, and there are, by the way, just buyer beware, that there are kitchen fans that have been independently tested. In fact, you know which ones are? The cheap Newtones and Brones and the townhouse fans. Those are actually independently tested. You can actually get a graph on a curve of their CFM. But the large fans, the Decors and things like that, generally are not independently tested. So this part of it gets really, really messy. And I know there was a question in the previous class about makeup air. I don't know if this helps or whether I made it more complex here.
This will be one of your biggest questions you're going to face on the street. Are you guys really comfortable with this? Because you're not going to get a better source than Terry right now in this question.
Hey, another question I got is there a provision for like a wood stove in an attached garage? Yeah, say they put a wood stove.
Like a wood boiler you're talking?
No, a stove. A wood
Okay,
stove
okay,
in their garage.
okay. Well, technically, to the letter of
Attached to
the,
the house.
yeah, but to the letter of the code, the garage is exterior to the interior heating volume and should not be affected or affecting the house pressures. So that should be
I
an
agree, I
independent
just
thing.
wasn't sure if there was.
Yeah. Now there is one little side note I'll make, and I would say in the Lower Mainland, I would follow this: no NAFA, no makeup air. Doesn't matter if this is 3,000 CFM. No makeup air is required if there's nothing to back vent into that house. Having said that, those of you that build in cold climates, I would caution you a little bit. And there may be a call for using makeup air fans even in a non-NAFA house in a cold enough climate. My co-workers in Alberta scream at me for recommending no NAFA. He says, because in Alberta, in Edmonton, and Calgary, in the middle of winter, that kitchen exhaust fan, if it's big enough, will bring enough air in around the doors and windows to freeze the curtains and freeze the carpet. And it causes actual damage to the building. So they always recommend makeup air on large exhaust fans in colder climates. But it's not a safety issue. It's strictly I don't know. Anyway, I think I'm out of time. Welcome any questions, or I can talk to anyone afterwards. I know we're about 4 minutes to break, Catherine.
Yeah, I can ask some questions.
Is there a guideline somewhere for wood stove application, in respect to this, on how to mire through the makeup air requirements? We occasionally get people who still want wood stoves.
Yeah, and the basic, it's a very clear line. If it's not mobile home certified, it's a NAFA and it's a risk. If it's mobile home certified and it's installed to mobile home standards, it's non-NAFA. They are actually tested. A mobile home approved appliance is actually tested under a negative pressure. They're tested under 10 pascals negative pressure. So they will back vent, but it takes a lot to back vent them. Unless the homeowner opens the door when the kitchen fan's on, that's a different issue. But they take
You
100.
can't be stupid and kill yourself.
Yeah.
You've got to be really stupid, however.
Yeah, you need your barbecue to heat your house right.
So a mobile home certified wood stove brings 100% of its combustion air from outside, and it's gasketed and sealed duct right into the firebox.
Now, are those most of the Regencies and things that are out there, do they have a product?
Not all of them.
Yeah.
No. You have to actually look for that MH. It's Warnock Kersey MH standard.
It's printed on the label.
Yeah.
So it ain't there. It doesn't meet the requirements Terry's outlined.
The brochures usually say, so when the homeowner's looking, it says in the brochure that it's mobile.
Right.
Thank you.
Most of the ones I've seen it.
There are even some fireplaces that are mobile home approved. Well, they're not really fireplaces, they're built-in wood stoves,
Right.
but they look like a fireplace. They're high efficiency, and they are mobile home approved.
And then if you have a homeowner that won't go for, say, a mobile home approved
Well, then we
unit, then you've got to go through.
then we potentially have that requirement if we're greater than half an air change per hour. So that's the game you have to play. Is you can downsize your kitchen fan, you can go to non-NAFA, or you can pay for makeup air.
Got it. Okay. Yeah, that's great. Thank you.
No trouble. Any other questions? If not, I thank you all for coming. Thanks for your time and hopefully contributed something.
Thanks very much, Terry. Well,